Hello students, welcome to this YouTube channel. Today we are going to learn our new lesson of class 12 physics, that is ray optics. So we will start our new topic. First of all, we know about the meaning of this word ray optics. Okay. Here the word ray means the path of light and optics means the study of light. Okay, so ray optics means study of path of light. Study of path of light. Now light is very important. To see any objects clearly, light should be there. Without light we cannot see objects around us. So when light falls on any objects, the objects gets illuminated, the light rays get reflected to our eyes, and then only we can see the objects clearly. Okay. Without light, suppose in a dark place, in a dark room, we cannot see the objects. Okay. So what is light? Can we define light? So light is a form of energy, or it's an electromagnetic wave. So electromagnetic waves has the different frequencies. They are arranged in a sequence that is called electromagnetic spectrum. In that spectrum, first radio waves came, radio waves, then after microwaves, then infrared rays, then visible light came, after UV light is there, then X-rays, and last gamma rays. This is the electromagnetic spectrum. So here we go from left to right, wavelength goes on decreasing. Wavelength, that is we denote it as lambda, goes on decreasing, and frequency of these waves goes on increasing. Here we are dealing only with visible light having the range of wavelength 4000 Armstrong unit to 8000 Armstrong unit. In visible light there are 7 colors, that is called Vibgyor, having the 7 colors. So these 7 colors we can perceive with our eyes, ranging from wavelength 8000 to 4000 to 8000 Armstrong units. Okay, further we will study in optics. There are 2 kinds of optics we will study here. First one is the ray optics, that is also called as geometric optics, and second one is the wave optics. So what is the difference between these 2 types of optics? In ray optics we are dealing with the macroscopic phenomena like reflection of light, refraction of light, reflection and refraction of light, and simultaneously in this wave optics we are dealing with a microscopic phenomena like diffraction of light, interference of light, polarization of light. These phenomena we cannot see with our naked eyes, and here the objects we are dealing have the dimensions equal to the wavelength of light. In diffraction phenomena we are performing the experiment of Young's double slit experiment. So in that experiment the slit width is nearly equal to the wavelength of light incident on it. So we can observe the diffraction pattern of light clearly. Also in interference of light, the light passes through a small aperture and the size of that aperture is nearly equal to the wavelength of light. Then only we can see the interference pattern clearly and we observe the wave nature of light. Okay. And also in polarization, the light is get polarized at certain angle. So these phenomena are the microscopic level and the dimensions of these objects are comparable to the wavelength of light. And in reflection we are dealing with mirrors, image formation by mirrors, lenses, prisms. So these objects having the dimensions greater than the wavelength of light. Here we observe the refraction with our naked eyes, therefore they are called macroscopic phenomena. Now we will study here only ray optics, and first we will study about the reflection of light. Before that, we know that the light always travels in a straight line. So this we should remember these points, that light travels in straight line. Second thing is, the path of light is called ray, termed as rays, and number of rays or bundle of rays is termed bundle of rays is called as a beam of light. So these points we should remember while study about the ray optics. Now we will study reflection of light by plane surfaces. Okay. Here we will see about reflection and different cases in detail. Suppose we have a plane surface here. This is the plane polished surface, and we draw a line perpendicular to this surface, that is called as the normal to this plane surface. And suppose a light ray incident on this plane surface making some angle with normal. This is the incident light. This light get reflected with the same angle, that is called as angle of reflection. Here it is angle of refraction. This light is reflected in this way. So here these two angles are equal always for a plane polished surface. So here we can write angle of incidence is equal to angle of reflection. This is always true for all the conditions, all the surfaces. Okay. Now second thing, here we note that the plane of incidence, plane of reflected rays, and the normal, these all lie in a same plane. Okay, angle of incidence, normal, reflected ray, these all are in a same plane. So this is the case of reflection by a plane surface. Now this we term it as a case 1. Case 2, suppose if we have a spherical surface. Suppose this is our spherical polished surface. So how the light will reflect from this spherical surface? So for this we will draw a normal passing through the center of a sphere. This is the normal, and a ray of light is incident on this spherical surface making an angle of incidence I. This ray of light get reflected with the same angle, that is angle of reflection. So in this way light gets reflected from this spherical surface. Now we consider a third case, that is normal incidence of light on a plane surface. Suppose this light ray incident normally on this plane surface. So how will this ray get reflected by this plane surface? So the light gets reflected in opposite direction to the incidence of light. This light get reflected with same angle, making zero angle with normal. Here angle of incidence is equal to angle of reflection is equal to 0 degree. Okay, because this incident ray falling normally on this plane surface, making angle 0 with normal. That is the case of normal incidence of light. Okay, all these three cases, do you understand? Now we will study about the formation of image by plane mirrors. So this topic we will see in our next lecture. So we stop here. See you in our next lecture. Goodbye.